Powerful mud pumps pick up mud from the suction tank and circulate the mud downhole, out the bit, and back to the surface. Although rigs usually have 2 mud pumps, and sometimes 3 or 4, normally they use only one at a time. The others are mainly used as backup in case one fails. Sometimes, however, the rig crew may compound the pumps. That is, they may use 2, 3, or 4 pumps at the same time to move large volumes of mud when required. Rigs use one of 2 types of mud pumps: triplex pumps or duplex pumps. Triplex pumps have 3 pistons that move back and forth in liners. Duplex pumps have 2 pistons that move back and forth in liners. Triplexes have many advantages. They weigh 30% less than a duplex of equal horsepower, or kilowatts. The lighter weight parts are easier to handle, and therefore easier to maintain. The other advantages include: they cost less to operate. Their fluid end is more accessible. And they discharge mud more smoothly. That is, a triplex's output doesn't surge as much as a duplex. One of the most important advantages of triplex over duplex pumps is that they can move large volumes of mud at the higher pressures required for modern deep hole drilling. Triplex pumps are gradually phasing out duplex units. In a triplex pump, the pistons discharge mud only when they move forward in the liner. Then, when they move back, they draw in mud on the same side of the piston. Because of this, they are also called single-acting. Single-acting triplex pumps pump mud at relatively high speeds. Input horsepower ranges from 220 to 2200, from 164 to 1641 kilowatts. Large pumps can pump over 1100 gallons per minute, over 4,000 liters per minute. Some big pumps have a maximum rated working pressure of over 7,000 psi, over 50,000 kilopascals, with 5-inch 127mm liners. Here's a schematic of a triplex pump. It has 3 pistons, each moving in its own liner. It also has 3 intake valves and 3 discharge valves. It also has a pulsation dampener in the discharge line. Look at the piston at left. It has just completed pushing mud out of the liner and through the open discharge valve. The piston is at its maximum point of forward travel. The other 2 pistons are at other positions in their travel, also pumping mud. But right now, concentrate on the left one to understand how the pump works. The left piston has completed its backstroke, drawing in mud through the open intake valve. As the piston moved back, it lifted the intake valve off its seat and drew mud in. A strong spring holds the discharge valve closed. The left piston has moved forward, pushing mud out through the now open discharge valve. A strong spring holds the intake valve closed. The left piston has completed its forward stroke, the full length of the liner, completely discharging the mud from it. All three pistons work together to keep a continuous flow of mud coming into and out of the pump. Crew members can change the liners and pistons. Not only can they replace worn-out ones, but they can also install different sizes. Generally, they use large liners and pistons when the pump needs to move large volumes of mud at relatively low pressure. They use small liners and pistons when the pump needs to move smaller volumes of mud at relatively high pressure. In a duplex pump, the pistons discharge mud on one side of the piston and, at the same time, take in mud on the other side. Notice the top piston and liner. As the piston moves forward, it discharges mud on one side as it draws in mud on the other. Then, as it moves back, it discharges mud on the opposite side and draws in mud on the side where it had earlier discharged it. Duplex pumps are therefore double-acting. Double-acting pumps move more mud on a single stroke than a triplex. However, because they are double-acting, they have a seal around the piston rod. The seal keeps them from moving as fast as a triplex. Input horsepower ranges from 190 to 1,790, or from 142 to 1,335 kilowatts. The largest pump's maximum rated working pressure is about 5,000 psi, almost 35,000 kilopascals, with 6-inch 152 millimeter liners. A mud pump has a fluid end, power end, and intake and discharge valves. The fluid end of the pump contains the pistons with liners, which take in and discharge the fluid, or mud. The pump pistons draw in mud through the intake valves and push mud out through the discharge valves. The power end houses the large crankshaft and gear assembly that moves the piston assemblies in the fluid end. Pumps are powered by a pump motor. Large modern diesel-electric rigs use powerful electric motors to drive the pump. Mechanical rigs use chain drives or power bands, belts, from the rig's engines and compound to drive the pump. A pulsation dampener connected to the mud discharge line smooths out surges created by the pistons as they discharge mud. This is a standard bladder-type dampener. The bladder in the dampener body separates pressurized nitrogen gas above from mud below. The bladder is made from synthetic rubber and is flexible. When mud discharge pressure presses against the bottom of the bladder, nitrogen pressure above the bladder resists it. This resistance smooths out the surges of mud leaving the pump. Here is the latest type of pulsation dampener. It does not have a bladder. It is a sphere about 4 feet or 1.2 meters in diameter. It is built into the mud pump's discharge line. The large chamber is full of mud. It has no moving parts, so it does not need maintenance. The mud in the large volume sphere absorbs the surges of mud leaving the pump. A suction dampener smooths out the flow of mud coming into the pump. Crew members mount it on the triplex mud pump suction line. Inside the steel chamber is an air-charged rubber bladder, or diaphragm. The crew charges the bladder about 10 to 15 psi, 50 to 100 kPa. The suction dampener absorbs surges in the mud pump suction line caused by the fast-moving pump pistons. The pistons constantly start and stop the mud's flow through the pump. At the other end of the suction line, a charging pump sends a smooth flow of mud to the pump's intake. When the smooth flow meets the surging flow, the impact is absorbed by the dampener. Workers always install a discharge pressure relief valve. They install it on the pump's discharge side, in or near the discharge line. If for some reason too much pressure builds up in the discharge line, perhaps the drill bit or annulus gets plugged, the relief valve opens. The open valve protects the mud pump and system against damage from overpressure. Some rig owners install a suction line relief valve. They install it on top of the suction line, near the suction dampener. They mount it on top so that it won't clog up with mud when the system is shut down. A suction relief valve protects the charging pump and the suction line dampener. A suction relief valve usually has a 2-inch or 50 mm seat opening. The installer normally adjusts it to a 70 psi or 500 kPa relieving pressure. If both the suction and discharge valves failed on the same side of the pump, a high backflow or a pressure surge would occur. The high backflow could damage the charging pump or the suction line dampener. The discharge line is a high-pressure line through which the pump moves mud. From the discharge line, the mud goes through the standpipe and rotary hose to the drill string equipment.